discussion of the machine learning algorithms. In that particular case, in the earlier session, we have seen the KNN, and then before that, we observed the logic behind the naive Bayes usage. Okay. Now, what we are trying to do is we'll try to understand the intent behind the decision trees. Because, as a typical machine learning practitioner or typical data science engineer, we should have the complete understanding of this topic, guys. Okay. Because, the decision trees are very much helpful in the processing of both classification problems and as well as the regression problems. Okay, so this is the first thing. And second important thing is either I can go with the continuous data or categorical data. Okay, because as if I'm saying some sort of the regression, definitely it is giving us some kind of the numbers. If I'm saying the classification, yes or no kind of thing. It is processing the yes or no, true or false, those kind of the categorical aspects. So it is understood that decision trees are suitable for both classification and regression, and as well as the continuous and as well as the categorical kind of the data. Now, the main important thing is let me show you how I can make use of the decision tree and what is the appropriate theory behind that particular decision tree orientation. So just have a look on this, guys. Just I'm pulling some kind of the compiled data for us. So just I'm pasting here. So where you can have a look on this convention. Okay. Now have a look on this, guys. Just if you are referencing the narration, okay. The decision tree is basically a type of supervised learning. Of course, we are dealing with the supervised learning, and once this is over, then we'll move back to the unsupervised learning. That is mostly used in classification problem and works both for categorical and continuous input and output variables. So the main benefit of this decision tree usage is no matter whether I'm using the continuous variable such as numbers or I'm using the categorical yes or no, true or false kind of the categories. And as I said, it is helpful for both classification problems and as well as the regression problems also. Okay, there is no restriction like I'm going only handling the classification problem. Of course, we can make use of the regression problems also. And most importantly, because I thought of starting the support vector machine, but before that, I thought of giving you some essence of the algorithmic orientation of the machine learning. So we started with this decision tree understanding. It is one of the most widely used and practical methods for inductive inference. Inductive inference in the sense, suppose that you observe, guys, some example I will give. Suppose we are having every quarter, third quarter, second, and first quarter. And then based on that, we can see the results of the fourth quarter. Maybe in the appraisal process, the employee, how he is doing. Okay, maybe he is publishing some articles and he has given some kind of the conference or seminars and he has cleared his certification. Okay, so now if you observe, maybe in the first attempt he cannot clear, and second attempt he has given some other benefits to the company. In the third attempt, of course, he got the certification also, assume that. So in the fourth quarter, is actually we need to give the hike or we need to perform some kind of the increment on his basic. So considering all these kind of things, we can come to the general conclusion. Okay, general conclusion in the sense as he's performing some sort of reasonable work and he's very much attentive in work and all these kind of the activities. So we can offer him the appropriate hike with the members who are satisfying all these kind of the criteria, whichever we have put. So these are all nothing but specifications, specification 1, 2, and 3, and we are making a general consideration. This is what we call the inductive learning. Okay, inductive learning. Maybe you are having the idea about mathematical induction. Friends, mathematical induction. What do you mean by mathematical induction? Suppose n equal to true for 1 and n equal to true for 2 and n equal to true for k. Based on that, n is true for all. Okay, n is true for all. Similarly, what we are doing here is as a part of understanding this particular thing, just we are making use of okay inductive inference process of reaching to a general conclusion from a specific example. Now, friends, if you remember in your engineering days, there is a concept called divide and conquer. Okay, divide and conquer. And what this rule does is just if you are talking about the quick sort procedure or else your merge sort. Okay, all these binary sets, all these things belong to the category of the divide and conquer. What do you mean by this divide and conquer is suppose I'm having a problem and that problem will be divided into sub problems. Problem 1, problem 2, and problem 3. Again, it is divided into some more sub problem P1A, P1B, P2A, P2B, A, P. May not be same. Sometimes it may be having other chunk also. Now, what we are doing is simply we are solving these particular individual portion of the data, and the appropriate result will be sent back to this thing, maybe result P1 and result P2 after getting all the results. Okay, and then we are finally we are seeing the result P3, and this will be combined result RP1, RP2, RP3. Okay, so divide and conquer means one larger problem we are going to split into the corresponding sub problems, and we are going to solve those problems, and finally we are getting the result. Okay, this approach we are following in the decision trees. Now have a look on the diagram. So this particular diagram, what it says is just if you are referencing, let me paste once more, guys, so that you can have the clarity. Okay, now you observe here. Okay, so just we are starting with a particular analogy of the starting node, and then we are subdividing the problems. Okay, and then we are having some kind of the outcomes according to the specification. So the here it is looking like a tree. Okay, just we are having a kind of the starting point, and then we are having certain kind of the child nodes, all these kind of the conventions. So this is very much similar to the tree kind of the architecture. So we can name this as a tree. And this particular tree, especially in our machine learning algorithms, we are making use to perform some kind of the decisions. Okay, to make use of some kind of the decisions. So this thing is known as the decision tree. This is known as the decision tree. Up to this, we are pretty clear, guys. Like whatever the activities I'm having, just I'm making use of that convention, and we're going ahead. But the understanding is, guys, how do I make use of this particular decision tree in solving the problems? Now, let me pull one more example, guys, for us to understand this particular thing in a better way. So, just we can make use of this another thing. Like if I'm seeing there is a temperature observation and whether the play is going to happen or not. We assume that some cricket, okay, we are planning with our friends. And maybe a small analogy we are doing, like based on the appropriate weather condition, whether we are going to play cricket or not. If you see these things, these are known as the terminal nodes, friends, actually. These nodes are the terminal nodes, where these terminal nodes give the results, actually. Okay. And remaining node, all these kind of things, just we can make use of the decision nodes. Okay, these particular nodes are having some kind of the condition, and based on that particular condition, we are going to get the results. So let us understand this particular example. Outlook, okay, sunny, and of course, humidity is high. then we are not going to play. Okay, even outlook is sunny, but humidity is normal, then we can play. So here no represent no play, S represent we are playing. Play is there. Now you see here the other option, overcast. Yes, and as I said earlier, guys, there is not always the requirement of definitely there should be some kind of the decision or some kind of the condition. Rather, what you can see is you can make use of this specification and overcast is there means we are not going to check anything. Obviously, it reads to play. It is raining, for example. The drizzling is there as well. That it rainy kind of thing. Now, raining, and one more condition is along with that rain, do we have any wind? Do we have any wind? And if wind is strong, there is no play. So, because rain itself is a dangerous signal, and we are having wind also, then obviously our outcome is there is no play. But rain is there, a drizzling or somewhat, and wind is very weak. There is a normal wind. Then in that particular case, we can play the. There is a chance of playing the cricket. So now, if you are observing these kind of the approaches, there are many dimensions and many kind of the situations are there, and finally we could able to conclude whether we are going to play or not. Okay, up to this is fine, friends. But the main important aspect in understanding of the decision tree is, and before going to launch the mathematical part, because our intention is not to only theoretically settle down the things, but we are trying to understand the mathematics behind that particular algorithm. That's how we are following, because everywhere you are getting some kind of the notions like applications and all those things. Along with that, our intention is to study the basis of that particular thing. Okay. Now, if you refer this thing, guys, before going to the background of the mathematics or statistical functionalities of the decision tree, let us try to understand which are all the applications I can make use. Because now you can decide as a machine learning practitioner or as a developer, should I go with the decision tree or not, or else at least you can take a decision like for these kind of the applications I can elect the decision tree as one of the choice. Now, in that particular case, the most commonly used applications are credit scoring models, like friends, CIBIL kind of aspects. And moreover, whether we need to sanction the loan to the customer or not. So maybe that is also one of the important convention or application. So in those particular cases, based on the customer's dimensions like age and as well as the education and whether he is married or not, he or she, and he is a job or else self-employed. Many things would be there. So to achieve these kind of the CIBIL scores and all these kind of credit score models, we should make use of we can make use of this decision tree as a best thing. And medical condition, friends, like like we are having some kind of the diagnosis. Okay, especially in the medical diagnosis, the accuracy must be very clear, friends. So for those kind of the applications also, I can make use of decision tree. And then marketing studies of the customer satisfaction. Here, maybe some kind of the malls and some kind of the companies, what they do is after purchasing the product, okay, they may give us some kind of the feedback form. Okay, so like what is your experience with our shop, online, maybe offline? And how the appropriate members received you, and how you enjoy the ambience. Is there any suggestion, or how is the product? And do you want to come again, or else do you want to make use of the offers we are giving? All these kind of things. So finally, after taking the feedback, then there should be a kind of outcome, friends. Actually, outcome in the sense whether that customer is satisfied or whether the customer is interested to come back to our store again or not. So these kind of use cases or applications are pretty straightforward in terms of the decision trees. Now, the other point, friends, because applications can be any more. Maybe you can roughly say in manufacturing, in civil, and in mechanical devices. And whereas even in case of the medical diagnosis, card scoring, banking sector, insurance, I can say plenty of things. But what I should confirm is what is the significance? What is the benefit of electing this decision tree? Because that probably gives us the confidence. Though applications we have seen, but still our interest is in what way these particular applications, if I'm integrating or if I'm implementing these applications with the decision tree, then what would be the benefit to me? What is the advantage? The first important thing is, friends, easy to understand, explain, and interpret. Here, the point is maybe you have implemented some task with the decision tree. Maybe for the client or else for the other team member, you need to explain or interpret the appropriate implementation. So, in terms of the decision tree, which is giving the full-fledged observations, and you can easily explain. Okay, it is easy to understand, explain, and as well as interpret the appropriate implementation. Moreover, as I said, maybe the data, so continuous data or else categorical data, whichever kind of the data, that particular thing is not a constraint. Your data type is not at all a kind of the constraint related to the decision tree implementation. So no matter whether you are using the continuous or categorical or those kind of the data items, absolutely fine with these things. And most importantly, non-parametric. Friends, here the term parametric is something like some assumptions we are having. Okay, especially if you are talking about the regression, in the regression aspect, I will explain. But regression is having some sort of the assumptions, guys. Like, those kind of the assumptions generally push that the user should assume some of the aspects practically whether they are feasible or not. Irrespective of that, the algorithm itself, the model itself is having some assumptions. That is what you call the parametric model. But whereas your decision tree is not assuming anything, so that it becomes the non-parametric method. Obviously, guys, non-parametric methods are powerful and accurate when compared with the parametric methods. Okay. And most importantly, for every data scientist, the best important part is he has to maintain the feature engineering. He has to maintain the pre-processing of the data because data comes in all shapes, but it is the responsibility of the developers who has to maintain that particular convention. So the data exploration and so as to identify the important features because maybe I'm having some 100 features I should know that whether those particular features are important for my implementation or not. For those kind of the conventions, friends, definitely we should come across with these significant of the variables or variable importance plot. For that kind of thing, we are having the support of the decision tree. Okay, it is not only easy to understand, and data type is also flexible, and it is a non-parametric method as it is not giving any kind of the parameter orientation. And one more important thing is it is helping the corresponding users or developers in such a way that to identify the variable importance and significance of the variables. Okay, this is also one of the important consideration related to our decision tree. Okay, right. So these things are reasonably okay, but most importantly, the understanding, because now I don't want to reveal the drawbacks of the decision tree, but rather what I'm doing is just I'll continue with the terminology, and then we'll see the related aspects. Like if you are referencing the decision tree kind of thing, it is good for all these kind of the parametric kind of aspects and all. And we have seen some of the advantages. Along with that, let us come across with the terminologies. Now, if you observe this notion, if you consider these kind of the observation trends, suppose if I am considering this as a root node, is a starting node actually, the beginning or start node. Most importantly, friends, splitting specifies that Suppose I'm having some feature 1, feature 2, and feature 3. And the decision tree should decide on which feature the split must be there. Okay, now going back a little, we're having this diagram actually. Should I consider sunny or overcast or rainy? And within that also, based on these particular three things only, I can say that whether the play is going to happen or not. Or else, in a simplest way, let me give you this example. Suppose I'm considering ninth and as well as the 10th class students. Assume that for nationals, we are selecting a team. Okay, so simple under 18 or something like that. There is some kind of the cricket team we need to select from the district. Assume that kind of the scenario. And here again, I am considering the gender also. Okay, male and as well as the female. Okay, this is the gender and this is the class. Now there is a time whether I need to go with the split of class or whether I need to go with the split of the gender. That means the decision should be made on the class or the decision should be made on the gender. For this, I'm having the concept of the splitting of the node. Most important thing, friends, because in the discussion of the navy base in the earlier session, we have seen some conditional probability. Like there, we have seen some conditional probability and how we need to give the importance for each and every feature. That concept we have seen. But whereas in terms of decision tree, there is a key point is splitting of the nodes. Okay, on what basis? Okay, I should apply the split aspect, and I'll explain various mechanisms where you can apply in terms of the splitting. Okay, because there are 2 to 3 methods are there. One method clearly we can see. Other two methods also I'll give in a brief kind of thing, so that you can understand what is the intent behind using of those three methods in the learning of decision tree. Okay. Now, coming to the other aspects, this decision tree, which is a decision node actually. So here it is giving that kind of yes or no kind of the convention or true or false kind of the convention. Based on that, the remaining things follows. Okay, here terminal node is nothing but the node which is not having any further chains. Okay, because if you consider the root node, this is a child one and this is child two, the terminology related to the decision tree. And for this particular child one, again, we are having one more child, but it is a terminal node. There is no further child, so that we can say that as a terminal node. That is the ending node or the targeted or terminated node. So that is what we call a terminal node. So, but all these kind of things, see guys, here A is a parent node. Okay, this is the parent node. B and C. Okay, so B, C are the child nodes, and to this particular child node, we are having the parent node. Okay, similarly, if you consider this thing, if I am assuming this as a D is a parent node, and E and F, E is a terminal node, F is again a sub-parent actually, because this is also having some sort of the child, so that we can say the other nodes. Okay, so the E and F, parent node of E and F is D, and for this D, we are having one terminal node, one subtree actually. This again it resembles as a subtree kind of thing. That's what I said. Recursive method or inductive learning or divide and conquer, all are alternatives to the decision tree. Now we are equipped with the kind of the terminologies. Just to a little up, if we are going, we try to understand what exactly a decision tree and how we are making use of advantage of the decision tree and for which kind of the applications I can make use of the decision tree. That thing we have seen, and thereafter one example we have seen like in what way the decision tree is helping us and advantages along with the applications. Now, what we have seen some kind of the terminologies. What is a root node? What is a parent node? What is a terminal node? All these kind of things we have seen. So the most important part, as I am saying, how I can split the appropriate node. Is there any mechanism for it? Yes, exactly, friends. The most important thing is the very first thing is based on the Gini index. I can decide the split of the nodes. And second is the chi-square actually. This particular chi-square 4 also, we can use the as a split node, we can use this chi-square. Third is information gain. Okay, information gain. So if you observe, friends, why I'm teaching this mathematics behind this thing is as a data scientist or as a machine learning developer, you need to understand the internal mechanisms of the on what basis split is happening. So, but practically, if you are implementing with respect to PySpark, or else if you are implementing with Python, this scikit-learn library, okay, is providing the appropriate tree model, decision tree, and there you can specify the strategy, whether you are using the Gini or chi-square or information gain. So don't worry about that. In the programmatical aspects, you can conveniently specify the parameters. But as I said earlier, to completely understand the power of decision tree, we need to study about the Gini index. Now let us get the information about this particular Gini, because this Gini is something like which is giving us some sort of understanding. But before that, as I said, just let me pick up a scenario where this particular scenario helps us to understand the implementation. Okay. So here I'm publishing this scenario, guys, where this particular scenario gives us, as I already mentioned, there is a class of some audience set of people where these set of the people are interested in playing of the cricket. Now it is the responsibility of the machine learning engineer by using these three, actually Gini, information gain, or chi-square, which is the best split? Maybe I can go with the gender, or split on the height, or split on the class. Okay. So now, if you are referencing this scenario, I'm having the 30 samples, the total, maybe male, female, all these guys are having some sample of 30 students were taking. And out of these 30, 50% are willing to play the cricket. Maybe from male and female, if I'm considering together, I got some 50% of the people are willing to play the cricket. Now here, the features or variables are genders, as already we have seen boys and girls, and class, ninth or 10th, and height of that particular members. Okay, so these three are the variables. And now our interest here is to create a model to predict who will play cricket during the leisure period. Because as a physical director of that particular school, he has to decide, he has to get the handsome people so as to form the groups. Maybe that is a small scenario we are taking. Now, this scenario can be taken as a nationals or international teams or whichever. Maybe you can change the variables like instead of that particular class, you can specify on how many matches he has played and what is the track record and how many hours he is practicing, something like that. Okay, so all those kind of things. Here we are taking for the sake of the observation, we are making use of this convention of specification. Okay. Now, the very first thing is, as I said earlier, the very first thing is just we need to go ahead with the Gini index. So let me define what exactly the genie is, because the most important point is the tree should decide. Okay, the tree should decide how we are going to split the corresponding data. Okay, though, so this particular split is based on the observation. So for that particular purpose, what we are doing, guys, here, have a look on this. What is the definition of this particular Gini index, and in what way we are going to implement that? Okay, however, we'll give one example, and thereafter you can practice the remaining things. I'll show you some one or two cases related to this particular observation, and the next important thing you can perform. Next other things. Okay, so one by one we'll try to see, friends, what do you mean by a Gini index? Because in out of three, first measure is the Gini index, so as to split the appropriate nodes from the tree. So Gini means if you select two items from a population at random, then they must be same class, belongs to the same class, and probability of this one is pure. Pure and impure means, guys, suppose if the sample I am taking from multiple sets, and you see here only one type of data I am having. Here I am having another type of the data. but here I am having combination of the data. These two are belongs to the pure in the sense, friends, only one type of the data we are having. This is nothing but the impure data, impure set. Impure in the sense it is a mixture of positive and negative, and it is combination. Many other things are there. So just we are giving preference to the pure kind of thing. That is the first thing. And of course, it is not only the property of decision tree. Gini works for both uh, categorical, success or failure, true or false, yes or no, all these kind of things. But most importantly, guys, Gini is only helpful if you're having the binary split. Binary split in the sense you need to take some data between male or female, ninth or 10th student, and between 5.5 feet and 6 feet. Okay, only these binary kind of the splits only, Gini is best suitable. And in most of the cases, guys, especially in the decision tree, our splitting is based on the binary only. Okay, generic thing, yes or no kind of thing, male or female, some class of audience, all these kind of things. Now, if you observe this particular cart, actually cart is expansion of classification and regression tree. See here, classification and regression. You may be having some surprise because classification is one set of the algorithms in supervised learning. Regression may be another set of algorithm in the supervised learning. But as you know, if you are considering the decision tree, there is no restriction on the type of the data. There is no restriction on the type of the class. Maybe that for the classification problems or for the regression problems, both the problems you can make use of this regression tree. Okay. And now let me calculate the Gini index because guys here the Gini index is a formula actually. Like if you are referencing this particular Gini kind of thing, P is nothing but probability of positives. Q is always known as 1 minus P or negative probability or negative probability. And once you compute the Gini for the individual nodes, you have to consider the weighted Gini. Weighted Gini is friends here. Always remember that this term is most important. Weighted Gini or weighted mean or whatever. Suppose I'm having item 1, item 2, and item 3 assume that. And we calculated the Gini value for all these things. We got value 1, value 2, and value 3. So what we are doing is based on the strength of that, because suppose 10 people are there from data science, 20 people are there from data engineering, 30 people are there from big data. Assume that. Now we need to give due respect for these number of people's opinion also. That is what we call the weighted or weightage. So according to these members, we are giving the weight as 1. According to these members, weight as 2. And based on the participation. According to these members, weight as 3. Suppose here 5 members are participated. The score is 5. Because only 3 members only participated. Weight is 6. And out of this big data, only 3 members participated. 3 into 3, 9. So 5, 6, 9. So weighted means just you can take. Similarly, after implementing the particular Gini, you have to observe that the weighted part of it. Just let me give you some more examples so that you can realize that what exactly we can see. So very first thing is I want to split on gender with the Gini index. A small calculation, friend. Don't worry because we are always scary about the mathematics and statistics. But now I'll simplify those kind of things for the sake of you. Again, what should I do is just I need to pick up the appropriate example for us. Now we are considering two cases actually. One is split on the gender and another is split on the class, as said earlier. So let me pick because we need to have that numbers with us so that we can make use of the convention. So just I am making use of this thing. Have a look on this guy. Very simple diagram where this the left to you is the gender and this is the right side is class we are having split on the class. And along with that, a total 30 students we are having. And out of 30, 15 members are willing to play. And from the female gender, we are having total 10 students. Only 2 members are interested to play the cricket. Whereas from the male category, we are having 20 students, and 13 members are willing to play the cricket. Okay. Now our interest is I need to check whether I should go with the gender or class, because as I said, split. Okay, split based on which kind of thing we are considering gender and as well as the class, and based on the Gini score. Okay, based on the Gini score, we need to decide whether we should go with the gender or the class. Okay, now again I'm pasting this diagram, guys, for the clarity. Now let us try to implement. Hope all are with me. So just if you are referencing this Gini, okay, so split based on the Gini, split with the Gini index on the gender column, on the gender column. What is the first step, friends? First, we need to compute see here, see the steps in the Gini. First, we have to compute the subnodes Gini index, and then we have to compute the weighted average. Now, let me go through that. Okay. Now, the very first point, what I am doing here is Gini index for subnode female. First, I am giving the female category, and female category, what is the Gini value? What is the formula, friends? P square plus Q square. This is the formula actually. Now, what is the P? P means the positive probability. Okay, so here female members, how many are willing to play, friends? 20% out of these things. This is the 20% of the people. So that means I can say 0.2 probability. Just you can apply the square plus Q means what? Negative probability. 1 minus 0.2. What is the value? 1 minus 0 point is 0.8 whole square. Okay. So for the female, after computing this total thing, we'll be getting some kind of 0.68 or something like that, some value. Okay. For the sake of us to maintain the timing, so just I computed this particular thing for us, guys. Similarly, the second important thing is the Gini value for male. Gini value for male. Now, how do I calculate how many members are willing to play? Just to go to the male, here observe, guys, 20 members, 20 male students are there, 13 are willing to play the game. So 65 percentage. So 0.65 whole square. This is the p value plus 1 minus 0.65, that is q, 0.35 whole square. And the final value is 0.545. See how simple it is. Okay, first we need to consider the corresponding gender, and then you can make use of the male or female kind of the thing, and you can specify what exactly the Gini value for male and as well as the female. But here the story is not ending, friend. The third point is we have to compute, okay, weighted Gini. Okay, weighted Gini for gender. Okay, weighted Gini for gender. Now, for this particular thing, friends, there is a simple thing again. We're having the weighted Gini means what? What is the total strength, friends? 30. Out of 30, 10 members only willing to pay. And what is the value we got for the female? 0.68. That we have to multiply. Just we have seen the weighted average. Plus, out of 30, 20 male students are interested to play. And what is the value? Just now we have computed 0.545. 0.545. Now, after computing all these kind of things, we'll be getting 0.5933. This is the Gini weighted value of gender. Weighted value of the gender. Now, what is the other class, friends? We have to see split on the class. Okay. Now we have to decide whether should I go with the gender or is the class. First, let me do this thing actually. Okay, Gini on class. Gini on class. How many classes I am having? 9th and 10th. Here also same for 9 p square plus q square. For 10th p square plus q square. Let us start with the ninth standard. Okay, so just we are split on class. Just we are making use of the class. Don't worry, friends. Simple only. Okay, so the very first thing is Gini for class ninth. Okay, Gini for class ninth. Now, if you go back to the image, just you focus on this portion, guys. Class ninth actually, how much percentage are willing to play? 43 percentage. So what you can do is for the ninth class, just I am getting the 0.43 whole square plus the class 10th also. I'm having some class 10th also that class 10th will see, but this is the p value. Now we need to have the q value. What is the q value, friends? 1 minus 0.43. We'll be getting the 0.57 actually. And after computing this particular value, we'll end up with 0.5098. I pre-computed for us. And second step is Gini for class 10th. Okay, now how many members are there from 10th who are willing to play from this particular thing? 56 percentage. Okay, so just what we need to do for the 10th class, just I'm calculating the Gini. 56 percentage, 0.56 whole square plus 1 minus 0.56, that is 0.44 whole square. Finally gives that 0. Somewhat 5072, like that it gives. But here, one more thing is weighted Gini of class 9th or 10th. How do I calculate the weighted Gini, friends? Total, I'm having 30 students. How many are there from 9th willing to play, and how many are there from 10th willing to play? We should go back. And out of this thing, student willing to play. Okay, so out of 30, okay, out of 30, class 9 and class 10. So just we are having 14 and 16 actually. 14 members are willing and 16 members are willing. So just what we need to do here. So just I am making use of total figure. And here I am having 14 members. And the corresponding Gini value we computed as here we'll take as 0.5098 and we can round that to 0.51 because the value is greater than 9 rounded. Now, out of the 10th class where we have seen 16 members are willing to play, total 16 out of 30. Okay, so this thing also 0.5072, which is also having greater decimal point as 5. So what you can do into 0.51. Now, as a final computing, we are getting 0.51. Now you observe guys here, we got two Gini value, Gini of gender, Gini of class. Gini of class is 0.51. Let me go back and observe what is the Gini of gender, 0.59 actually. Okay, so 0.59. Let me paste here, 0.59. Now, what is the thing, friends? Gini of the gender, okay, Gini of the gender is higher than the Gini of class. Okay, so hence, important point here, hence, node split, okay, hence node split will take place using gender. So this is the background behind the people always talking about the Gini index and all. Nothing else, guys. There is no big deal actually. It's a simple kind of thing where internally, just it is even if you are giving the gender or whatever the kind of the conventions, male or female, or whichever the conventions we are following. So here we are considering only gender on only split on the gender. We got some 0.59 and split on the class. We got some 0.51. Always higher Gini value, whichever the equation or whichever the split got the higher Gini, we should go with that particular thing. So here, obviously, we end up our searching process with higher Gini on gender. So the split will be taking place on the gender only. Okay. So this is how you can empower. Okay. You can follow the activity of the gender, all these kind of the computing. And one more thing I will give you guys. So rather than going with the chi-square I will give as the kind of self-learning. Okay, but however, I will paste some kind of the additional information with you. You practice that chi-square, but after this Genie, the most important kind of thing is information gain, and even implementation also very simple. Information gain, and this particular information gain is comes under the category entropy. You might have heard about the term entropy, and how I can define is can be calculated as very simple narration, guys. How I can calculate the entropy is minus p log p minus q log q. See how simple the equation is. In the earlier example of the Gini, we have seen p square plus q square. Now, as an equation of the entropy, we are seeing that equation as minus P log P minus Q log Q. And moreover, and, as you said, Dr. Uma, you are saying information gain, but we are talking about the entropy. What is this? Let me explain that, guys. Okay. Now, my information gain is equal to, because I can able to get entropy directly with the formula minus P log P minus Q log Q. So what I'm doing here is 1 minus entropy if I'm doing, then I can able to get the information gain. I can able to get the information gain. Now you can ask the question: if Gini is more, okay, if Gini is more, then vote for that split. Okay, this is the most important thing. Now, how do I vote for the information gain or entropy? Let me clarify that, guys. If entropy is low, okay, vote for that. And if your information gain, if information gain is more, okay, friends, then you have to vote for that. Okay, you have to vote for that. I am not revealing the chi-square kind of thing. However, I will be sharing the document with you. So just have a look on that, because the most importantly, we are either go with the Gini and as well as the information gain, or else sometimes this thing is also known as the entropy. Okay, with the respect to entropy kind of thing. So now you are very eager to observe the calculation. Let me pull the calculation here. So directly I'll paste that particular calculation so that you can easily observe the things. Okay, so this particular calculation on the same kind of the category. So what exactly I'm having the diagram. So this diagram is same, split on the gender and split on the class. Let me paste this diagram for us. Okay, this is common. Okay, where this is the base point for understanding of splitting of the corresponding criteria. And then let me give you the flavor of splitting on the gender. Okay, already I have calculated. For the sake of you, just let me explain this particular thing also. Okay, now have a look on this, guys. Very pretty simple compared with that thing. It's pretty simple calculation. Now, as I said earlier, your entropy is minus P log P minus Q log Q, where P is the probability and Q is the negative probability. That means 1 minus P. This we know. Now, what we're trying to understand here is, guys, uh, so here, first I'm splitting on the gender as how we have seen in the information gain. In the same way, you can apply for the entropy calculation also. The formula for this entropy is minus P log P minus Q log Q. Now, if you see the entropy for parent node, okay, parent node is actually this one. Okay, all the male and female. Okay, just we are having 15% positive rate out of total 30. So 15 by 30 because probability of true. Okay, these are willing to play the cricket. 15 by 30 log of 15 by 30 minus what is the Q value, friends? Out of 30, if I'm saying 15 are true, obviously remaining 15 are false. So the same thing. So the computing here is 1. Okay, because the entire logarithmic equation, okay, just is giving that one value, same values, na? So it is yielding 1. Next important thing is for the female, because not only the parent node, just we are going with the another category, how many females are interested and how many males are interested. Out of this 10 students, guys, see here, total 10. So total female 10. Only 2 are willing to play. Your p value is that. What is your p value? Obviously, 1 minus p, 8 by total 10. So minus of 2 by 10 log 2 by 10 minus of 8 by 10 log 8 by 10. So here 2 by 10 is p and your 8 by 10 is q. Similarly, for the male kind of the candidates, 13 people are willing to play and out of 20. See here, total 20, 13 are willing to play. Obviously, 7 members are not willing. So in the male category, your 13 by 20 is p value and your 7 by 20 is the q value. Based on that, we are calculating female entropy value is 0.72, male entropy value is 0.93. But in case of the Gini, how we have done our weighted average, here also we need to see the weighted average. Because for the female kind of thing, we are having out of 30, only 10 members are willing, 10 students are there. So 10 by 30 into the female entropy is 0.72. That we are multiplying. Similarly, here out of 30, 20 male students are there and their entropy value is 0.93. Total we got 0.86 entropy value for the gender. Okay. Similarly, split on the class. Okay, so here we computed an entropy for the gender, which is 0.86. So gender entropy is 0.86. Now we got the entropy value of class. Class means 9th or 10th class. Now we are discussing that is 0.99. Now what is our analogy, friends? If you lower the entropy, then you have to select that. What is the lower here? 0.86 is less than 0.99. So we have to vote for this. Okay. So likewise, friends, entropy of split is lower. This gender is lower. So the split must be placed around the gender. In both the cases, friends, surprisingly, not surprisingly, I can say as a kind of the recheck, we have seen gender split with the help of the Gini give the higher value. Okay, this is the observation. Similarly, gender split with entropy given the lower value. Friends, your Gini must be high. Gini high, whereas your entropy must be low. That is the reason why we are making use of the convention of calculating the split values. See, friends, until we are practicing, until we are understanding the underlying assumptions of this particular thing, we are not able to get the actual things right. That is what maybe takes some hours, definitely. But once you learn means as all of us are in the same field or machine learning or data science, as a kind of the developers or practitioners, we should be very cautious about the internal mechanism of this algorithm. Once you are familiar with these kind of thing, now you can easily interpret. If someone is saying my entropy is more, then you can oppose that. No, no, no. If entropy is more, if entropy is more, I cannot go with that split. And someone is asking if my Gini is very less, then you have to go for other split. Okay, because if Gini is high, you need to take a decision on the appropriate splitting. Okay, like how we have seen in the gender and as well as all the other kind of the aspects. Uh, Now, if you are referencing one more point, actually, I promised you na the chi-square. Chi-square, I'm not going to explain, guys, but rather what I can do is just I'm giving you some kind of the inputs, okay, where how you are going to calculate the chi-square and all those things. Definitely, it is pretty easy, guys. Like how we have done our Gini and all these entropy on the same kind of the table. So just I'm giving you the kind of the example related to the chi-square. So this particular chi-square is also one of the kind of the parameter where you can use. But only the distinction here is, guys, in the Gini and in the uh, information gain or entropy, we have used the probabilities with P or Q kind of thing. But in your chi-square, okay, so there are certain aspects we need to compute as a table. How many nodes are there and how many willing to play cricket, not playing. From this only we are generating it. Two members are willing, that means eight are not willing. Total like this. Expected members to play cricket, five, and expected members to play cricket, 10. Like that, we can, because 50% of the people, no, 50% as I said, out of 10, 5 we are expecting expected not to play. This is also 50%. So deviation on play cricket. See here, actually 2, but our expectation is 5. So calculate as minus 3. Actually 7, but our expectation is 10. This is 3. Likewise, you can easily compute the other kind of thing, deviations, and then playing of the cricket, not playing of the cricket probability, and finally compute the chi-square. So similarly, chi-square on the class actually. So class means ninth or 10th class students, they want to play the cricket and it is 1.46. So this is 4.58 on the gender. Whereas if you are referencing the other thing, we are getting only 1.46 on the class. Now we can see that chi-square score for split on gender is higher than the split on the class, hence no split will take the gender. So the final observation is like this, guys. Okay, the final observation is which are all the two things should be high. Your Gini must be high, your chi-square score must be high. Okay, whereas low, your entropy must be low. And what should be high based on this information gain? Your information gain must be high. So with this, we are having some other last aspect, friends. Apart from this, how can I refer the betterment in the understanding of the decision tree? Because there are certain key aspects we need to consider in the management of decision tree, and which are all the key parameters in the specification of the decision tree. Okay, there are certain aspects, friends. Okay, very simple. Just if you observe these kind of the notion, your decision tree should dependent on these parameters. As I said, a tree notion like root node, and thereafter we're having the decision node 1 and decision node 2. Again, we're having terminal node, and sometimes we're having some other decision node like that. We're having some more aspects, decision node 4, and here I may take the terminal node 2 like that. So minimum samples for node split, because node split, earlier we have taken gender and as well as the class. If I'm keep on taking the number of splits, then it kills a lot of time. So we have to take the minimum samples for the gender. Though I'm having 1,000, I can take some from this particular population. I can take some sample from that particular population. Okay, and minimum sample for a terminal node. Even for the terminal node also, I need not go for all the yes or all the no kind of thing. To randomly select some of the nodes so as to come up with the analogy of understanding. Maximum depth of a tree. Depth means how many nodes are there in between root and as well as the terminal node. If you are keep on doing the decisions, automatically the tree will grow to some extent, and that definitely gives the betterment. Whereas in the other aspect, maximum number of terminal nodes. Okay, so we have to set some sort of the constraint, friend. Whereas if I am abnormally taking the number of nodes and all these kind of things, definitely it leads to some complexity. And we have to put some kind of the constraint on the maximum features also. It doesn't mean that always I'm having 100 features. I should go with all the 100 features. Okay. So these are all some of the parameters we need to consider in the observation. And tree pruning in the sense, friends, actually pre pruning and post pruning. Okay. So what do you mean by this pre and post pruning is while applying the algorithm or while considering that particular tree, before applying the model, can I apply some kind of the pruning technique? Pruning means avoiding the unnecessary paths. Okay, avoiding the unnecessary paths. Like, with the help of our Gini index or information gain or entropy or else our chi-square, you can decide how do I prune this particular text and how do I handle these kind of the situation. So majority of the times, friends, after making use of this particular tree, the post pruning, okay, is really helping us to generate the best decision trees. Okay, the best decision trees. Now, before taking the leave, so just will before terminating the session, let me give you the key takeaways. Okay, where you can revise the things. We have introduced the decision tree, the kind of the tree structure, and then we have seen some kind of the terminology. And this particular terminology observes the decision node, terminal node, all these kind of the things. And then we have seen some sort of applications and advantages related to the corresponding trees, and most importantly, the split of the nodes. Split of the nodes. And there we have seen uh, three techniques: the Gini index, and then friends, chi-square, and thereafter we have seen some information gain. And of course, this information gain is computed with the entropy. Actually, that 1 minus entropy is the information gain. Now, thereafter, we observed that the high values and low values. The high values are Gini must be high, your chi-square must be high, and your information gain must be high. Whereas low in the sense your entropy must be low. Only out of these particular four parameters, entropy must be low. This thing is constraints and pruning techniques, tree pruning techniques we have seen. Okay. So with this, we can stop here, guys. Let me know if you are having any doubts so that I can clear.